manufacturer knows that their items have a normally distributed length with a mean of 11.9 inches and a standard deviation of 1.2 inches. If one item is chosen at random, what is the probability that it is less than 15.3 inches long? So we're trying to find a probability. That's the question here. So what is the probability that is less than 15.3 inches long? The probability is based off of a distribution that is normally distributed. So before we go any further, do yourself a favor and sketch out a normal distribution, just a nice small bell curve. This will help you get your information organized in such a way that it will help you solve the problem visually. And most students are visual learners, so this is generally a very effective way of working these out. The mean of this distribution is 11.9 inches. The standard deviation is 1.2 inches. So the mean is located right in the center. We'll go ahead and label that. Now, what we want is the probability that we have an item chosen at random that's less than 15.3 inches long. So 15.3 is somewhere over here to the right of 11.9. But because we want it to be less than 15.3, we would shade the area under the curve to the left of that value. Now, to figure out what that area is, that's the probability, is the area under the curve. We are going to use the function in the calculator, normal CDF. And normal CDF can take up to 4 inputs. The first two are the lower bound of your shaded region, which in this case would be negative infinity because we shade all the way as far left as we can go. But what I'll put there is negative e to the 99 when I type that into the calculator because we just need something really small. There's no infinity key on the calculator. The upper bound is 15.3. The last two inputs are a mean and standard deviation. So, oops, mu and sigma, so the mean and standard deviation. So the mean in this case was 11.9, and the standard deviation was 1.2. The nice thing about this function is that it will take this mean and standard deviation and calculate z-scores for each of the first two inputs, and then use normal CDF for z-scores. You could calculate z-scores first and then run your normal CDF, but this is one of the easier ways. So second distributions, normal CDF, the lower bound is negative infinity, so negative second comma to give me the e 99. And you don't have to use negative e to the 99. Some folks use like negative 10,000 or negative 9,999, just something that's small. That's all that really matters. As long as it's 10 standard deviations from your mean, it's generally small enough. All right, so 15.3 is the next input. Then we have 11.9. And finally, 1.2. Hit calculate, and it will come up with your probability 0.9977. Now, some of you may have seen something different on screen when you use the normal distribution function. And that's because some of the later calculators have what are called stat wizards. And if you're using the stat wizards, the normal CDF function comes up with a menu where you can type in the different values instead of you can type them into this menu instead of typing them into the function. Either way, it's going to put the values into the function. So, the lower value, negative infinity, upper value, 15.3, The mean is 11.9 and the standard deviation is 1.2. Hit paste and you'll see that it just types it in exactly as we did it in the previous example. So it's just a helper function, that's all.